Hi, STAT students. Welcome to section 11-2. We're going to take this in 2 days. So we're going to do tests using contingency tables. And today we're just going to test for independence. So we're still using our chi-square table and our test statistic, and we're testing 2 variables. So yesterday, section 11-1, we tested 1 variable for goodness of fit to see if it fit into an expected pattern. So the test of independence of variables is used to determine whether 2 variables are independent of each other or related to each other when a single sample is selected. So this is going to sound a lot like what we've talked about already for our chi-square. And we did talk about independence way back in chapter 4. So I don't know if you remember talking about probability, but we're really wondering if variables are independent of each other. So if we're thinking in terms of probability, the probability of one thing happening is not affected if the other thing happens. So the probability of A happening is the same as the probability of A given that B happens. And it's the same as the probability of A given that B does not happen. So they're independent. It doesn't affect the other item. So I'm sure you remember our chi-square test statistic is still the sum of our observed minus our expected squared over our expected. So it's the same formula. We just calculate things a little bit differently. Degrees of freedom, since we are looking at 2 different variables, I kind of had to scooch this in here. I'll put this up here. Our degree of freedoms is our number of rows minus 1 times our number of columns minus 1. So you got to kind of think about and look at your table. You'll be able to tell. We'll talk about that in just a minute. We know that O stands for our observed values, and E is our expected frequencies that we will need to calculate. We've got 2 assumptions for our chi-square independence test. They're the same as our goodness of fit test. We need to make sure that we've got a random sample and all of our expected values are greater than or equal to 5. If they're not, we might have too small a sample. So contingency tables. So it looks a lot like our expected values tables, except notice I've got a table down here and I've got this labeled as observed. So we're looking at 2 different things. We're looking at whether a person asked is a doctor or a nurse. And then we're looking at whether that particular person prefers the new procedure for whatever it is, the old procedure for whatever it is, or they have no preference whatsoever. So we've got a table that has 3 columns. And our table has 2 rows. So when we're talking about our degree of freedom for this case, we do our number of rows minus 1, so 2 minus 1, multiplied by our columns, 3 minus 1. So 1 times 2, a degree of freedom we're going to work with here is a 2. Okay, so that's the first thing I wanted to make sure I mentioned. The table is different because we've got 2 different things we're looking at. To calculate our expected values. So notice this is our observed. We're going to have to go over here and calculate our expected. Our expected value is equal to the row total times the column total, all divided by the grand total. So if you notice, I did put these columns, including totals, for these particular data. So we've got to do a little bit of math work. So in order to calculate my expected preferred new procedure, so if I were trying to find this box right here, I would go over and do some math. So first let's add things up. Let's see. So preferred new procedure regardless of doctor or nurse is 150. This one would be 200, and no preference, there's 50 people. If I go across, looks like 200 nurses were asked, and it looks like 200 doctors were asked. So that means there's a grand total of 400 people. So that's going to be the denominator of my expected value formula. So if I want to do the prefer new procedure right here for nurses, I'm going to do the row total times the column total. So the row total would be 200. Let's see, I'm just right over here. Nurse, try that again. New procedure, nurse and new. I would do my nurses 200 times my new procedure right here, 150. And that's all going to be over my grand total of 400. So in order to fill that in, check my calculations. I've got that at 75. I notice because doctors and nurses are all 200, when I go to do doctors who prefer the new procedure, that's going to be the same calculation. That's still going to be 200 for the row, 150 for the column divided by 400. So that's going to be 75. Same thing when I go to do my prefer old procedure. Nurses, there's 200 times 200. Divide that by the grand total. I'm going to get the same value. Go through and calculate these. Make sure that you get the same thing. I really didn't need to keep totals columns over here, but we can double check. There still should be the same number of people who prefer the new procedure. There still should be the same number of doctors who were surveyed, even for our expected. So it's kind of just a built-in double check. I don't typically fill in these because that just seems like more work. All right, so that's what we're going to need when we go to do our chi-square test statistic, our observed minus expected squared over our expected. But we needed to know how to calculate that before we did anything. All right, so let's talk about our chi-square test for independence. You know the steps already. We find our hypotheses and claim. We calculate our test statistic. So remember, in order to do that, we're going to have to find our expected values. Expected values this time are a little bit more. Values, row times column over total. Once we've got that, we can go ahead and calculate our chi-square test statistic, which is our sum of our O minus E squared all over our expected. Once we've done that, the bulk of the work is done. Step 3, we know we're going to find our p-value. P-value requires us to go to our chi-square table. And don't forget about the new DF, which is number of columns minus 1 times number of rows minus 1. Step 4, make a decision. And step 5, summarize. Make sure you use context. And I'm hoping that you do remember for making a decision, if your p-value is less than or equal to alpha, reject H sub O. So our hypotheses, this is where we get into the weeds a little bit, because remember our hypotheses, we don't have our old parameters and all those things when we go to do this test. So we're going to use context, but we need to just say for H sub O, our variables of blah, blah, nurses and doctors who prefer which procedure are independent. Our H sub O is always independent. So that's what we're assuming, that they have no effect on each other. So we either reject or do not reject that. Our H sub 1 is that the variables are dependent upon each other. All right, so let's do a test. We've got ourselves, let's stick to, actually, let's skip this procedure preference. Let's go to the one with music CDs sold. We already did this is our observed. We already did the expected, so we could go back and do that, no problem. I want to go to this one, music CDs sold. So our sales of CDs in millions by genre related to the year in which they occurred. Use alpha equals 0.05 level of significance. So I've made an observed table, and then I put an expected table so we can do our calculations. And first, though, I want to talk about our hypotheses. So it says, are the sales related to the year in which they occur? So we're wondering if the genre of music is related to the year in which they occur. And when we say it's related, remember our H sub O is always going to be that they are independent. So I'm going to say for H sub O, CD sales by genre are independent of the year sold. The year in which the sale occurred, they were sold. So for my H sub 1, CD sales by genre are dependent upon the year sold. So a specific year might be a specific genre, dependent upon the year sold. So independent is always our H sub O. All right, so let's calculate our expected. In order to do that, remember, we need to have row and column totals. So let's see, I got to do a little math here. So 2023, it looks like 177 CDs were sold. In 2024, I've got 151. R&B sold altogether in those 2 years were 84, 66 country, and 178 rock. I've got a grand total of 328. So remember, in order to do that, so to do my 2023 and R&B expected value, I'm going to do my total 2023, so 177, times my total R&B, 84, divide that by my grand total, 328. Go ahead and check your numbers for your expected values. See if you got the same things. Notice I didn't round them. We can have decimals for these things. And please make sure you notice that my R&B is still 84 sold for expected. It's just distributed differently because we're looking at the proportions, what we expect to see there. All right, so now that we've done all that, we're going to go ahead and do our chi-square test statistic. Chi-square test statistic depends on that expected value. So for step 2, chi-square is equal to, so remember, it's our sum of our O minus E squared over E. So we can go through this whole thing. You just have to pay super close attention to what you're doing. So I've got a 48 minus 45.33 squared over 45.33. Go ahead through those and calculate. I'm going to take a break so you don't have to watch me writing all day. How are your chi-square calculations coming along? I wrote out my whole thing. I calculated it all. I ended up with a chi-square value of 0.561. Pretty tiny, right? So that indicates that, I mean, maybe we're not going to reject H sub O, which means that the sales are independent. But let's look at this. So in step 3, I need to go to my DF, or to my chi-square table. My DF, I've got 3 rows. I've got R&B, country, and rock. And I've got 2 columns, 2023 and 2024. So 2 times 1 equals 2. So I'm going to go to a DF of 2. I'm going to search for a 0.561. And it looks to me like P is greater than 0.10. It's going to fall off the left side of our table. So if I compare that P to my alpha, which we said was a 0.05. Remember, these are always one-tailed. We're not going to do alpha over 2. My P is absolutely greater than my alpha, which means I am not going to reject H sub O. If we think about this, if I'm not going to reject H sub O, that means I like this. So I am agreeing that CD sales are independent of the year in which they were sold. So step 5, genre of CDs are independent of the year sold. So they have no bearing on each other. It doesn't mean that 2023 might have been a big year for rock and 2024 might have been a big year for country. There really isn't any kind of relationship. So that is chi-square testing for independence. Thanks for hanging in there. Lots of calculations, lots of calculator work. Have a great day.